Welcome back to another session of probability example. And here it says that in a state lottery, 4 digits are drawn at random one at a time with replacement from 0 to 9. Suppose that you win if any permutation of your selected integers is drawn. Give the probability of winning if you select A, B, C, and D. Now, permutation actually is with replacement, but order does matter. So, exponent is with replacement, but order does not matter. Permutation is with replacement, but order does matter. So I'm going to call the simple s n of s. Now I want to say it's equal to 10 to the power of 4. Why did I choose 10 to the power of 4? It's because we have from 0 to 9, which is 10 digits, but we are drawing 4 digits, and it says with replacement. So here, that's an exponential right here. So 10 digits with replacement, and you're taking 4. So you have 10 digits 4 times. You can choose basically. So that is this one. Now it says for A, give the probability of winning if you select 6, 7, 8, 9. Now you see here, all of these only have 4 numbers. So basically, your first priority here is to neutralize that 4 numbers. So I will call NA, the first one, 4 factorial. Why? Because permutation involves the factorial. So the probability of winning for A, which is 6, 7, 8, and 9, is going to be the number of A, which is 4 factorial, which actually is a number, divided by the number of S, which is the bigger picture here, which is 10 to the power of 4. This would be the probability of winning for A. Actually, let me just put it as probability of winning WA. This is the probability of winning for A, which is this one. A is the 6, 7, 8, 9. Now let's look for B. B now. We need to find the number of B. The number of B, remember, we still have 4 numbers, 6, 7, 8, 9, or 6, 7, 8, 8. We still have 4 numbers, so that 4 factorial is still going to be here, except this time we have 1 6. Actually, that's not 6.7, that's 6, and comma. We still have that 6, 7, that 4 factorial, because we got 4 digits in each of them. But in B, it's slightly different, because this time you have 1 6. So because you have 1 6, you have 1 factorial. You have 1 7, 1 factorial but now we have 2 8s, so that'll be 2 factorial. Yes, this is the other part of the method of enumeration, because we have a distinguishable permutation right here. Why do we have a distinguishable permutation? Is because one number is repeated more than once. So because we have 1617 and 1819 in the first one, then we didn't have to divide by anything. But in B, we have 1617, but we have 2 8s, so we have to divide by the number of 8, which is 2 factorial, because we have 2 8s. That would equal to 12 as the number for B. Now, the probability of winning for B is going to be NB, which is 12, over NS, which is 10 to the power of 4. And now let us go to, come on. Okay, it's not going. What's wrong with it now? Okay, this one. Okay, fine, this has to come. Now let's go to C. C is talking about, we have 7 7 8 8. So C 7 7 8 8, the number for C is going to be again 4 factorial, because we have 4 numbers, divided by, this time we have 2 7s, so we're going to have 2 factorial times 2 8s, 2 factorial. And that number would equal to 6. So the probability of winning for C is equal to 6 over 10 to the power of 4. Okay, never mind, no one will need that. So that's up. Now D, for D, we have 7 8 8 8. So the number, again, for D would be 4 factorial over, we have 1 7, so 1 factorial, and we have 3 8s, 3 factorial. And that would equal to, 4. So the probability of winning for D is 4 over 10 to the power of 4. This problem, I'm going to tell you, it's not easy, it's somewhat tedious, but once you understand the notion of distinguishable permutation, you will find it easy to do, because all you have to know is when you have something called distinguishable permutation, which actually is, it's a sort of permutation of one type, basically. It's different because when you have more than one thing in common, you can't just, you have to divide by them separately. So that's why we have to divide each 4 factorial by each of them separately, because some of them have more than one digit. So I hope you understood this problem. And if you have any question, feel free to comment. If you like it, thumbs up. If you don't, thumbs down. And that's it. Have a great day.